The velocity of a bullet has an upward component of 100 meters per second and a horizontal component of 328 meters per second. We're going to calculate max height, then we're going to calculate x, so the horizontal distance. First we're going to calculate max height though. So, first I'm going to draw my picture. It says there's a bullet. The upward component is 100, horizontal is 328. 328 is bigger, so I'm going to go horizontally, then I'm going to go vertically. This is our triangle. Theta will be here. So we have 328 meters per second, and then 100 meters per second on the vertical. Because it said it's going upward for 100, horizontal for 328. So first thing I'm going to do is I'm going to solve for VI and theta. The reason why is if you look at every single equation, it will have VI and theta. So to solve for VI, I am going to just use a squared plus b squared equals c squared. To solve for theta, I will do inverse tangent, opposite over adjacent, so 100 divided by 328 meters per second, and that'll give us theta. So if you want in your notes, I would write Pythagorean theorem, or find VI and find theta. So that's very important. So I already solved those, so you should get a value. Pause if I'm going too fast, but VI is going to be 342.9 meters per second. Theta is going to be 16.955 degrees. Okay, so I'm going to actually write out all our givens now. We also have acceleration in the y direction, which is always gravity. And our unknown is going to be max height, so that is y. We also always know something at max height. We always know VYF is equal to 0 meters per second. So I'm going to look for an equation that has y in it. So if you're looking at the equation list in green and in blue, you should hopefully only find 2 equations that have y in them. They are actually the top 2 in green. So it's going to be this equation and this equation. The first one, we're looking for y. We have the I sine theta. We do not have t. Theta is not 0, so this t stays. We'd have to do quadratic. So we're going to skip that for now. We might come back to it. Next one, VYF. We know it. At max height is 0. We know VI sine theta. We know A. We can solve for y. So we're going to use that equation to solve for y. So to get y by itself, we're going to subtract and divide. So you'll have y equals VYF squared minus VI squared sine squared divided by 2a. Our y value you should get is, when you plug in those numbers, should be 509 meters. Okay, so that is our max height. That's part A. So we are done. Part B, find x and assume it's a level surface. Okay, so it's telling us something. It's telling us to find x, but it's also telling us it's a level surface. What that means is that the path is going to look like this. It also tells us if we're finding x, our equation has to be one that has x in it. If you go through all of these equations, only one has x in it. This top one has x in it, so we have to use that equation. So we're going to have x equals VI cosine theta t. What you'll notice about this equation, we do not have x, we do not have t, so we have to find t. We're going to have to do another equation. So we're going to look for equations that have t in them. So this first one has t, this one has t, this one does not, this one has t, this one does not. So we're down to 3 equations. We're already using this one, so it can't be that. Now we're down to 2. The t here is in 2 different spots, so we'd have to use quadratic. I'd rather not. So I'm going to look at this equation. notice we only have VYF at max height, right? Because we have VI, we have sine theta, we have A. We have VYF. We don't have VYF. We have VI sine theta. We have A. We're looking for T. For VYF, the only VYF we have is at the very top. Okay, that was at maximum height. Thing is, because it is at a level surface, it's going to take half the time to get to this point where VYF is 0 as it would for it to go the total distance. We're looking for the total distance, right? So if we find this time, this is actually half of the time we would have to use for this equation. Okay? So we can use this, but we have to remember this only solves for half the time. So we're going to have to double it before we plug it in. So when I do that, we'll have VYF equals VI sine theta plus AT. We'll have VYF minus VI sine theta divided by A equals T. And remember, this is only half your time. You will get 10.19 seconds. Remember, this is only half your time. So I'm going to double it so I can plug it into this equation. So T is actually going to equal 20.39 seconds. Okay, now that I have that time, I'm going to plug it into this equation. I have VI cosine theta. I have T. I'm just going to plug in all the numbers. So we'll have 342.9 meters per second. Cosine of, was it 16.955 degrees. And then we're going to multiply it by time, which was 20.39 seconds. And this is going to get us an X value of 6,687.86, sorry, 0.74 meters. So that's how you do problem 2.